Last time we did 1, 1, right?
Yes.
That was on graphs of equations and things like that. So let's open that up to questions. Heidi? Which one? 31. Okay. Use symmetry to sketch. Y equals the square root of x minus 3. You know, I'm a little bit puzzled by honestly, the directions. I'm not sure how helpful they are in this one. I don't like that, but I'll show you what you could have done. Number 31, you know, if we square both sides, now, I mean, then if you take, you know, it's kind of like half of this. And then it would have symmetry, but like it is right now, it really doesn't have symmetry. So that's why I'm a little puzzled. You guys all know this, that when a problem like this is stated and there's a root, but you see no plus or minus sign, that means they want only the positive root. That's called the principal, P-R-I-N-C-I-P-A-L, principal square root. So they only wanted the positive root. Thinking about it this way does show you both roots. So anyway, it's kind of ironic, but symmetry doesn't help a lot. So what I would do, I don't know, I'd start plugging in numbers. You can see that some numbers aren't going to work, right? For example, we know that a number below 3 is going to cause problems. Why? Because that'll cause you to take a square root of a negative, and you can't, under the real numbers, you can't do that. So let me just write that down. So x has to be what? Greater than or equal to 3? Would everybody agree with that? So that means on a graph, crude graph here, doesn't that mean the graph will forever be on or to the right of this dashed line here? And what happens when we pick x equals 3? Won't the answer be 0? So 3, 0 is, I know, a point. Let's take another one where we definitely would know. What happens when x is 4? Right, you get 1. So 4, 1. And yeah, well, I'm starting to run out of space, but you're gonna get a kind of half of a parabola here. It's going to, the start of it's going to look like that. And that's, you know, I don't like that hint because there is no symmetry here. Now, had they had plus and minus, then we'd have had the bottom half of the parabola too, and then there would have been symmetry. So, I don't know, I'm a little bit ticked off at them for giving the impression there might be symmetry there when there was not. But, yes?
I'm going to do this to kind of get so like a 27.
27?
Put in, so you put in 1 for x.
Yes.
That's whatever you put in is for y.
Here, let me just quick put that on here. 27. So I can talk about it better. We have y equals x squared minus 2x. So you're saying, okay, what happens when you plug in 1? You know, this is real. By the way, I might as well start getting you used to this. This is another way of saying y equals, isn't it? And the nice thing then is you can do like, all right, what is f of 1? Which means what happens when you plug in 1, which is what you asked. And what do you get? And then, what happens when you plug in negative 1? Let's see, 1 squared is 1, and negative 2 times negative 1 is, so you get 3 this time. Now, did you notice how the symmetry tests, what did that tell you? No. We didn't get the same number. We didn't get the same number with the opposite sign. So this is looking like not much is going on here. Now, is that what? Now, what were you asking me?
So how would you graph that?
Well, when all else fails, make yourself a little T-chart. By that I mean a T. I shouldn't call it that, but it's just shaped like a T. X, Y. Pick some points. Make sure you pick a few positives and negatives and get 0 in there. Let's do 0 right away. What's f of 0? 0, right? 1 we already did. We also did -1. Let's take advantage of that. Let's do a couple more now. How about 2? And how about -2? I think that's 8, isn't it? Okay, now make yourself a little grid. Sorry this is so sloppy, but okay, we got the point 0, 0. We got the point 1, -1. -1, 3. 2, 0. -2, 8. Well, what I've got so far, it kind of looks like a parabola, doesn't it? At least I've got part of it. It looks like the bottom of the parabola is down here, and then it starts coming up again. And if you really wanted to know, you could pick a few points over here. You know, like what happens at 3? I get 9 minus 6, which is 3. So 3, 3. Yep, see how the parabola keeps coming up? Now I got enough. I could take a pencil and kind of roughly sketch it in, and that would be the end of that one. So when there is no symmetry, don't give up. Plot a couple points, see if you see any patterns. On you go. Yes, Michelle? Let's take a look. 53, everybody. What do they... A solution point, the meaning of that is that point is on the curve, or is on the graph, is on the circle. That is correct. Exactly. Yeah, yeah. So everybody see that? Good question. 53, they say you have a solution point. What is that? That means 0, 0 is on the circle. So like she said, that means you could plug in 0 for x and 0 for y, and it will work. Well, what's the cool thing about that? What's that going to let you find out? It's going to let you find the radius, isn't it? Because now, how far is it from -1, 2 to 0, 0? You could use the distance formula, and there's your radius. By the way, if you ever do that, do the distance formula to find a radius, don't find the square root, which is the last step of the distance formula. Why not? Because in the circle equation, what are you always going to do with r? Isn't it always r squared? So don't go through the hassle of taking the square root when in a few seconds you're going to square it again. Save yourself a little work. So if you got the square root of 88, and then you said, oh man, I got to simplify this. Well, there's no need to, because you're going to want r squared in a moment anyway, so just put down 88. So, other questions? Heidi? 61? All right, 61. Find the center and radius. Oh, okay, 61. I don't even have to write that one down, because, first of all, hopefully when you look at 61, everyone, based on last time, does that look like the standard form for a circle? Doesn't it look like that 1/2 is the h, and that other 1/2 is the k? And doesn't it look like r squared is 9/4? Yeah. So really, I can answer the question, what's the center of the circle? 1/2, 1/2. And what's the radius? 3/2. Yeah, 3 over 2. So that one was, if you're really watching for that standard form, 61 was just could be done by vision. Well, if you know where the center of a circle is, and you know what its radius is, how do you do that? All right, well, just make a dot at the center. What was the center? 1/2, 1/2? So if this is 1, then here's where the point 1/2, 1/2 is, right? And what's the radius? 1.5. So that means from there, I got to go 1.5 units in every direction. So that means we'll have like 1 point here, 1.5 up, 1.5 over, 1.5 down. So don't I just, now this is going to be really crude with this pen, but doesn't that mean I just have a circle that looks something like that? And that's good enough. So that would be, so once you know your center and your radius, you know pretty much what your circle looks like. Yes. Yes. Well, I see we're going to have to make a graph to do that, aren't we? Okay, a rectangle. I guess we're just having to do, I really can't do it without doing the problem. Let's see, I might have that. Let me just take a peek here. Yeah, I do. Okay, well, here's 65. You have a rectangle of length x and width w. Okay, and it has a perimeter of 12. So what I did is I said, why, if the perimeter is 12, doesn't that tell me something? So what I did is I said, all right, that's 2 widths, 2 x's, and 2 lengths, 2 w's. Add them together and I get 12. And I got down to the point where I could solve for w and find out that w is equal to 6 minus x. First, let me just stop there. Does that make, so in other words, I didn't really want, you don't really want, the whole lesson was stuff in one variable. The problem with the way this was is I had 2 different lessons. Can't do that. So what I did over here is by using this given perimeter of 12, I was able to get w down to an x state. So instead of w, let's call it what it's also, 6 minus x. Now I got an x guy and another x guy. And now what does it say? Find the area. So then I just took length times width. All right, so now you got your thing. You can multiply that out, and you can plot it. So if you multiply it out, what do you get? Okay. Actually, a couple things about this. The nice thing about the way it was stated up here is, can you see what happens? Well, what's going to make this multiplication problem come out to 0? When x is 0 and when x is 6. So that's kind of cool because what it tells us is, on the graph, I know that when x is 0, we're going to get a 0. And 1, 2, 3, 4, 5, 6. And when it's 6, I missed on the x-axis there, but so we at least know 2 points on the graph now. And does this tell you anything? Anybody remember that from before? If you have a negative, first of all, x squared, this is a parabola, right? And the fact that it's a negative tells me it opens downward. So I know the top's somewhere in between here, and shouldn't the top be halfway in between? Okay, well then what happens when you plug in a 3? Yeah, you get a 9. So there's the top. 1, 2, 5, 6. Where am I? I lost it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now you got a nice parabola that looks something like that. Now, I don't know, what was D? From the graph, Estimate the dimension of the rectangle that yielded the maximum area. 3 by 3. And that, sure enough, there's that point 33 up on the top of the parabola. So the height of the top of the parabola is the point where it had the highest area. I just didn't want to be laughed at, so I didn't sketch it. I'll try it. I'm really bad at this with this pen, but I'll try it. So you just basically got this parabola. Well, this didn't work out that bad, but yeah, I know. It looks like it's a parabola with palsy. It's a palsy parabola. But anyway, it's not real easy to sketch bigger curves on that thing. But you get the idea. That's supposed to be a parabola.
But how did you get 33?
Okay, our reasoning was, did you see how we figured these 2 points out? And the fact that this was a negative sign right here told me I knew this thing was upside down. So then I thought, well, doesn't that mean there's got to be a high point somewhere between these two? And aren't these things always symmetrical? So it's got to be right in the center. Okay, what's halfway between 0 and 6? 3. So now we knew 3 was the right point for the high point. And how did we know it came out to 9? We just plugged in 3. And you see that the result comes out to 9. So how we doing? Another question? Okay, let's see how far we can. Some old questions here. 1.2. Linear equations in one variable. Yeah, this is, I don't know. This is not, there's not a lot here. So, in a way, it's good that we had a lot of questions today because we don't need a lot of time. You know, I mean, look at the bottom of page 89. Example 1 shows you how do you solve a linear equation for the, you know, there's only one variable. How do you solve for the variable? That's called algebra 1. And you know, I don't know how you were taught it, but basically it comes down to the idea is to get the variable by itself on one side. In order to do that, you have to get rid of things. And you have to get rid of things in reverse order. By that I mean, you know the good my dear Aunt Sally thing? Well, you actually have to do that in reverse when you get rid of things. So if you had a multiplied thing to get rid of and an added thing to get rid of, normally you would do the multiplication first and then the added thing, but when you're doing algebra and you're trying to remove things, you would get rid of the added guy first, right? And then the multiplied guy. And so, you know, the good old equal rights amendment for algebra, do whatever you please to one side of the equation, just make sure you do it to the other side. And all those wonderful things. I'm not going to go through that, but that's pretty easy stuff. So that's like when you first had algebra in high school. Now, they get a little bit messier when you look at a problem like example 2 on page 90. So turn over to that. What's the only thing that makes that a little bit more complicated? Actually, 2 things. What are 2 things that make that a little bit more work than the one you just looked at? Yeah, and that would draw your attention because wouldn't you want to attend to the parentheses right away and do the distributive property? And maybe one more thing I will point out, and that is there's more than one x term here. So what are you going to have to do? You're going to have to combine these. And then do the good old equal rights amendment for algebra. Okay? Now, look at the top of page 91. Now, we throw in the next level of complexity, all those confounded fractions. Actually, I didn't really mean, personally, I like them, but I know how students generally feel about them. What do you, I have definite advice for fractions. It's called get rid of them. And it sounds like I'm prejudiced against them too. Get them out of my sight. Actually, the easy way to do it, whenever you have an equation especially, when you have an equation, you can do this. Just multiply both sides by the LCD. You know what I mean with the least common denominator? What is the least common denominator in that example 3? 12. So I don't do this. Yeah, I guess the book did that. They said, let's multiply everything through by 12. Now the left side is 4x plus 9x equals 24. And now it's just a good old straight line equation, and now you're in easy city from here on, right? Okay? Now it gets a little bit uglier in example 4. I like the, how the level of ugliness just goes up gradually here. Now in that one, it's a little bit harder to find the least common denominator. But that's still my advice to you. Find the LCD and then multiply both sides of the equation by that. Be careful though, because when you multiply the right side of the equation by the LCD, you really have to do the distributive property, right? Because there's 2 terms over there. What is the LCD in number 4? I know it's right in front of you, but don't peek. It's right below your eyes. We have x minus 2, another denominator is x plus 2, and a third denominator is x squared minus 4. Well, if your factoring skills are sharp, you realize that x squared minus 4 is just x plus 2 times x minus 2, and isn't that nice? That means, isn't that just your LCD, x plus 2 times x minus 2? So what's going to happen when you multiply, so there's you're going to multiply everything through by x plus 2, x minus 2. What will happen in the first fraction? The x minus 2's will cancel, and you'll just have x plus 2 on top. What will happen after the equal sign in the next fraction? The x plus 2's will cancel, and on top you'll have 3 times the quantity x minus 2. And what happens in the last fraction? Oh joy, oh joy. Both terms cancel. Yes? And all you're left with is that minus 6x. Now you have a straight line equation, and now it's good old algebra 1 again, right? I know I'm talking a strange language up here. Are you getting what I'm talking about, I hope? Okay. Well, let's look at some of the problems in the assignment and try to get a feel for the kinds of things here. Numbers 1 through 10 on page 93. It says in part 1, find out whether each value x is a solution. So, Michelle, this comes right back to that kind of that same lingo. What do they call it? A solution point? Yeah. Is x equals 0 a solution on that in that particular graph? And how do you find out? You just substitute it in and check if it comes out to be true. So 0. Let's see, I get negative 3 on the left. I get a 5 on the right. Let's see. Is negative 3 equal to 5? So that one's out, and then you just go on and you either get the ding 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 or the
Do you want us to show all that? Us putting that into the equation?
I would write down, 5 times 0 minus 3 equals 3 times 0 plus 5, and that'd show that 0 does not equal negative 5, not, or however you're going to write it, not a solution. Yep. Okay, so none of those are really any different. It's just that you have a little bit harder calculation when you get down to number 8, right? Let's do one on number 8. How about D? Does 8 work? Does D work? No, because 8 minus 8 is 0. The cube root of 0 is 0. And 0 never used to equal 3. And it still doesn't. So that one's out. All right. Let's go to part 2. Determine whether the equation is an identity or a conditional equation. All right, now I got to tell you what those are. An identity is an equation that's true for all values of x. Got that? It says, I don't care what you plug in for x, this baby's going to work. That's called an identity. And then a conditional equation will only work, when x is certain numbers. So, like, how about number 11? That's an identity. I don't care what you plug in for x. Aren't the two sides exactly the same? Yeah, that's just the good old Whenever you get down to a property like that, that's got to be an identity. How about number 12? Well, that's sure not a property, right? Because if you multiply out the left side, are you going to get the right side? No. But why is it conditional? Is there a value of x that could work for? Sure. Could I solve that? Yeah. I would get on the left 3x plus, here, let's just quick do it. Okay, I forgot. What number was this? Thank you. So we've got 3 times the quantity x plus 2. So this sure is an identity because, I mean, if you multiply the left side, you sure don't get the right side. So 5x plus 4. But that doesn't mean I couldn't solve it. And so we get 3x plus 6 equals 5x plus 4. What should I do next? Remember, I want to solve for x. Subtract 3x from both sides. Subtract 4 from both sides. Divide both sides by 2. Okay, that's a classic example of a conditional equation. It works, but only when x is 1. That's the way most equations are, right? They only work for one or a limited number of values. So there's a conditional. And I don't, did they ask you to solve them? No. So I went beyond. They just want you to say it's conditional or it's identity. Now, next section, 21, 22. Justify each step. Tell me what they did. Okay, I look at the first step in 21, the second line down, and what did they do? Subtract 32 from both sides is what I would say. What did they do from that line to the next? Well, they just did the subtraction. Yeah. And then now they have 4x equals 51. How did they get to the next line? Divide both sides by 4, and then just calculate. Okay. Next section, 23 to 38. To solve the equation and check your solution. All right, let's, somebody want to pick one? I'll let you just pick one. I heard a 32, so I'm going to do that. I heard others, but that was first, so. X minus 5, is that right? So solve. I guess we should do the distributive property first. Notice just a little weakness correcting the test in people working with parentheses and negative signs. A few of you don't seem real steady on that yet. Okay, combine like terms on the right. Okay, now, this is really weird. I mean, yeah, exactly. And what does the book call that? That's what they call an identity. I don't know, they didn't ask you to identify it. So, but you're right. You would just say all values of x. So, I mean, if you add 10 to both sides and subtract 9x, you get this. Well, that's always true. So whenever you have an identity like that, two things identical, that's telling you that every single number will work. 39, the next section says, solve the equation in 2 ways, then explain which way is easier. I wonder what I'll just let you do it one way on that part. I don't think that's that important. We'll skip 43 to 48 section. Okay, next section, 49 to 58. Find the x and y intercepts. This is a review. How do you find x-intercepts? Set y equal to 0, substitute it in, and see what x would be, right? How do you find x-intercepts? Plug set y. Did I just do the same one again? How do you find y-intercepts? Set x equals 0. Yeah. So you get the idea. And now, how would you report that? So, like for example, on 49, what's the y-intercept? Plug in a 0 for x, and you get 12, right? So 0, 12, yeah. Report it as an ordered pair. That's the best way to do it. Okay? What's the x-intercept for number 49? So this time you have to set y equal to 0. Now you've got 0 equals 12 minus 5x. You would probably, what, add 5x to both sides? You get 5x equals 12. And then divide both sides by 5, and you'd get x equals 12 fifths. So 12 fifths comma 0, again, ordered pair, would be your x-intercept. 59 through 70, whatever, through 80, I guess. Solve the equation and check your solution. If not possible, explain why. Yeah, I don't, well, let's do one of those. Now, to remind you of my advice, how about we do 74 as one example? 74. 1 over x minus 2. And then we want to add 3 over x plus 3. And that is equal to 4 over x squared plus x minus 6. Okay, the really good news is this is an equation, which means once you find the least common denominator, you can multiply through both sides by it, and you will have no more fractions. And that's definitely the goal. Well, in order to find the least common denominator, don't I have to factor this guy right here? And that one that's just a riddle 1 job, isn't it? Isn't it just, what, plus 3 and minus 2? And isn't that just what you kind of hoped it would be? Yeah, because aren't those the other two? So therefore, what is the least common denominator in this problem? It is x plus 3 times x minus 2. So I'm going to multiply, basically, each fraction by that. Sorry, I don't have a lot of room, but I'm going to try to sneak it in here. So you're going to multiply that one by that, this one by that too. Okay, in the first fraction, we have a cancellation, and what's remaining is just x plus 3 times 1. We all know what that is. Okay, second fraction. This cancels, and we get 3 times the quantity x minus 2. With a little distributive property, we know that equals that. And on the right side, it's easy city because everything cancels, and all we have left is the numerator, right? And now you just have yourself a really wimpy equation. From here, it shouldn't be very hard. So the big step is finding the least common denominator. And I guess we should go one more step because they said check it. Okay, watch. So we check it and we get 4x, what, minus 3 equals 4. Add 3 to both sides. It looks like x equals 7/4. Now, to check it, you really have to go back in the original. So when you're done with a problem and they say check it, you literally have to plug in, you know, the x value wherever it appears, okay? And you've got to do the arithmetic to show that that really works. And that's sometimes a little bit of work. Like in this case, we're going to have to mess around with some denominators. Yeah, here's going to be real fun. We got to do 7/4 squared plus 7/4 minus 6. And now you got to really do the arithmetic instead of just going, yeah, those are equal. You really, I can't tell that by looking at this. You got to go beyond that and show. And if you want to, it doesn't hurt, I guess. I mean, it's better than nothing to do it on your calculator. I guess I'm not, but it's good practice too. Now, here's your assignment. I don't think I showed it to you, did I? No. It's a little different today. I'm just going to have you do multiples of 3. Okay, there's good news and bad news. The good news is there's less problems. It means you do, you know, you're going to do 3, 6, 9, anything that 3 divides in evenly. Okay? The bad news is half of those are even, and they won't be in the back. The good news is it's less problems. So like a little bit of good news and bad news. You have a good one.